Okay, AP Psych class, welcome to our Unit 7 on memory and thinking and language. In general, it's just going to be referred to as cognition. Unit 7A is talking specifically about memory, so our introduction is just kind of a brief one, and we'll talk about intro to memory and encoding. And so let's talk about what memory is. Memory is really just the persistence of learning over time. And so a lot of this is connected, honestly, to what we did in Unit 6 on learning, right? There's really no sense in learning anything unless there's some longevity to what it is you have learned. And so if learning persists over time, we'd refer to it as a memory. When we discuss the processes of memory, we're going to talk in detail in later videos and discussions on how something becomes a memory. And so that's usually referred to in three processes. Encoding, which is putting the information into our brain. Storage, which is going to be somehow retaining that information. And of course, retrieval, getting the information back out for use at a later point in time. So really there's no sense in storing information unless it can be used at a later date. So obviously retrieval, accurate retrieval being, the key to good memory. And so we'll discuss each of those stages, encoding in this video, storage and retrieval in the next. You might remember from our 40 studies reading over the summer that Atkinson and Shiffrin have a model for memory known as the information processing model. And so although there are no actual places in the brain that are referred to as sensory, short-term and long-term, like I can't show you a model of a brain and point to this is short-term memory, their model or their metaphor for memory is still often used in discussions of memory. And so we're actually going to use a modified or a revision of Atkinson and Shiffrin's original model. But let's talk about this. When we first record remembered information, it's going to enter this metaphorical place known as sensory memory. So the initial immediate recording of information will happen here. Information here is very fleeting, right? Within matters of seconds, it's going to be gone. That process of encoding is going to take it to the second place known as short-term memory, right? We process the information here, right? It's encoded, it's rehearsed. And through enough practice, it's going to move to long-term memory or the quote-unquote storehouse of information. This is a very simplistic model, but easy to understand and comprehend. Some information, as we'll talk about in later discussions, kind of skips these first two stages and can be processed directly and automatically into long-term memory. And so that's a revision of the Atkinson and Shiffrin model that we'll have to discuss. And the second is that we will oftentimes not refer to short-term memory as short-term memory, but a newer understanding of that place or stage is that it's called working memory. And so this is where information is being processed, it's being used, it's being thought about. I think it's simply just because the terminology of short-term memory leads people to this misunderstanding that something is stored there for a short amount of time, which is indeed not true at all. And so working memory is probably a better description of that second stage, but the term short-term memory is so embedded in discussions of memory that we'll just have to use short-term and working as synonyms. Okay, and again, more on each of these stages and processes as we get into the unit, but there's kind of your overview. All right, so let's talk about that first process known as encoding. Okay, so let's talk about how we encode and what we encode. Okay, the first here is how we encode. Remember that our brains are not exactly like a computer. That information processing model that Atkinson and Shiffrin give us kind of makes us think we're like a computer, right? Using those three stages and three processes. But honestly, our brains work on that two-track mind, right, or that two-track model that we've been talking about, since the get-go. And so remember that things can be experienced using automatic processing and effortful processing. Okay, so when we talk about automatic processing, we're talking about the things that you can encode into your memory without any work, essentially. And what sorts of things would be a good example of that? Things like space, time, frequency, and then of course well-learned information. And so these are great examples about taking a test and maybe not remembering the answer to a multiple choice question, but remembering where it appeared in the book or where it appeared in the notes. Being able to answer my question, what did you eat for dinner last night? Being able to tell me these sorts of things, like when things happen, without, the kind of mundane randomness that we have in our brain. It doesn't necessarily have to, be worked at getting there. Okay. Something that is well learned, again, gets almost automatically processed, like the reading of the words on this slide. You've been well versed in the English language long enough that you just encode the meaning of these words without much work at it. Okay. Unfortunately, most of the information that you want to know has to be put in using effortful processing. Okay, and so effortful processing is what produces those durable and accessible memories. But effortful, right, there it is, right? It requires attention and conscious effort. So, unfortunately, just showing up to school doesn't make the information magically enter your brain, right? You have to work at putting it in there. And so, most of the time this is going to happen through rehearsal, right, or practice, right, conscious repetition of the information. And so really, that's kind of the key to storage, right? So rehearsal of the initial encoding or effortful processing. Okay, so again, practice really does make perfect. Two things related to effortful processing that are important to know, especially as students, are the spacing effect and the serial position effect. The spacing effect is just, research that's been done by Hermann Ebbinghaus that shows that distributed studying or practice is going to yield better long-term retention than if you cram. So I know we've been telling you this, but you don't like the truth, but the truth hurts, right? The distributed studying time. So repeated revisiting of material is much better than concentrated chunks of material. The reason that it's probably better is because of this second phenomenon, which is known as the serial position effect, right? That we have this tendency to recall the last and first items in a big long list of things, right? And so when you cram as you study, all you're really doing is remembering the very beginning and the very end of the cram session, but everything in the middle is gone, right? So small, concentrated tidbits of rehearsal spaced out over an extended period of time is what's going to be best for getting this encoded information to truly stick in long-term memory. So what do we encode? Is any number of things listed there, right? The levels of processing. We can encode visual images, right? We can encode sounds, or what we've heard, right? What we've seen, what we've heard. And semantic encoding is probably the coolest in that's encoding things into memory based on their significance or their meaning. Okay, and so while we use all three of these on a regular basis, know that for long-term retention, semantic encoding is the best. And so that's why that's a study technique, right? Making the information have meaning to you is way more likely for long-term retention than simply just, like memorizing the information, which is more of a visual or an acoustic way of processing it. Right, we've all heard of mnemonic devices, right? Those are those tricks, right, or memory aids that can help you better remember information. And so don't discredit visual and acoustic, right? Those can be used in conjunction with semantic encoding to get really durable memories. Okay, so visual imagery, right? Imagining things as pictures or images can help remember hard to learn information. Chunking things, which really just means organizing items into familiar groups, right? Like acronyms, right? Like HOMES as a way to remember the 5 Great Lakes. Is an example of chunking to make a mnemonic device. And hierarchies are another example. It's just hierarchies would be taking broad concepts and breaking them down into smaller, more manageable units, which requires you to apply meaning to things and requires that semantic encoding, which ensures, a more durable encoded information. All right, so this is just step 1, putting the information in, right? And so we'll do some examples of these things in class as we discuss this section, and then be prepared in the next video to discuss, storage, right? The retention of this encoded information, and ideally being able to accurately retrieve it or recall it at a later date and time. So bring any questions that you have with you to class, and as always, thanks for listening.